Welcome back to the AI cost optimization series on human mimics. In our last two episodes, we reduced unnecessary AI calls. If the same question comes again, we return the cached answer instead of calling the AI. But what if every question is completely new? Caching can't help. Imagine someone keeps pressing the send button over and over, or an application has a bug and sends hundreds of requests every minute. The AI answers every request. More requests mean more API calls. More API calls mean higher cost. So instead of controlling what users ask, we control how many requests each user can send. For example, we might allow only 20 requests per minute for each user. If they exceed that limit, the extra requests are temporarily rejected until the next minute. This is called rate limiting. It protects your application, prevents abuse, and keeps your AI costs under control.
Most users only send a few AI requests every day. But sometimes, one user or even a buggy application starts sending hundreds or thousands of requests. Every one of those requests creates another AI API call, and every API call costs money. Without any protection, that single user can quietly consume a large percentage of your monthly AI budget. That's why rate limiting is so important. Instead of allowing unlimited requests, we set a maximum number that each user can send within a specific time window. For example, you might allow 20 requests per minute for each user. If someone exceeds that limit, new requests are temporarily blocked until the next minute begins. Remember the difference between these two techniques. Caching reduces repeated AI calls by reusing previous answers. Rate limiting reduces excessive AI calls by preventing a single user from sending too many requests. Use both together, and you'll have a much more efficient, reliable, and cost-effective AI application.
Rate limiting works by tracking each user's activity individually. Every user has a unique user ID. Whenever they send a request, the system increases a counter for that user. The counter measures either the number of requests or the number of tokens used within a specific time window, such as 1 minute or 1 hour. If the user stays below the configured limit, the request is allowed, and the AI model generates a response as usual. But once the user reaches the limit, the application stops sending requests to the AI model. Instead, it returns a friendly message, such as, "You've reached your limit, please try again in a moment." This protects your budget because you don't pay for additional AI completions after the limit has been reached. It's important not to confuse this with the provider's global API rate limit. The provider's limit protects their infrastructure across your entire account. Your per-user rate limit protects your application and your AI budget by controlling how much each individual user can consume. In short, the AI provider protects its servers, while you protect your costs.
There are two common ways to limit how many requests a user can send. The first is called fixed window. It's simple to understand and easy to implement. For example, you can allow up to 5 requests every 60 seconds. Once the 60-second timer expires, the counter resets back to 0, and the user can send requests again. The drawback is the reset gap. If a user sends 5 requests just before the timer resets, and another 5 immediately after, they can briefly send 10 requests in only a couple of seconds. The second approach is called token bucket. Instead of resetting everything at once, each user has a bucket that holds a fixed number of tokens. Every request consumes 1 token. When the bucket becomes empty, new requests are temporarily blocked until new tokens are added over time. This creates a much smoother flow of requests, and naturally handles short bursts of traffic without the reset gap. When a user reaches the limit, your application has two options. The most common approach is to let the user click send, but the server blocks the request and returns a friendly message such as, "Too many requests. Please try again in a few seconds." Because the AI model is never called, you pay nothing for that blocked request. For an even better user experience, the application can temporarily disable the send button and display a countdown timer. Once the waiting period ends, the button becomes active again automatically. In practice, fixed window is a great starting point because it's simple and effective. But for production AI applications, Token Bucket is usually the preferred choice because it provides smoother traffic control, better fairness, and stronger protection for your AI budget. There are two popular algorithms for limiting user requests, and each has its strengths. Fixed window is the simplest to implement. It stores only the window start time and request count, making it ideal for prototypes and small applications. Its main drawback is the burst at the boundary between two windows, where users can briefly exceed the intended rate. Token Bucket uses a slightly more mathematical approach, but it provides much smoother traffic. Tokens refill continuously over time, allowing controlled bursts while preventing abuse. Both algorithms require only two values per user, and in distributed systems, they should use a shared store, such as Redis, so every server shares the same rate limit state. The rule of thumb is simple. Start with fixed window while prototyping, then move to token bucket when your application reaches production and real user traffic begins to expose edge cases. Hello. This is the lab part. In this lab, we'll show how to implement two methods. First one is fixed window, and second one is token bucket. Let's start. In fixed window, we have two main parameters, window time and max request. Here, I give example for window time to be 10 seconds, and the maximum request is 3. That means the user within 10 seconds is allowed to send only 3 times. After expired 3 times, user will be locked and not allowed to send any request to the model. This is first type, and it's named fixed window for rate limiting per user. Let's see how is pattern for user continuous send request for 14 time. First 3 request is allowed to send because it's within 10 seconds. But the remaining are blocked till reach exceed 10 seconds of the window. Then it start to allow again to this user to send his request. So, in this method, user allowed to send within the time window. Any requests exceed the maximum number of requests will be blocked. Now, we are talking about second type, second methods. That is the name token bucket. In this method, we define two main parameters. One is the bucket capacity, and the other is refill rate. The bucket capacity means how many tokens will the user take, and the refill rate, what the time after passed I should refill its bucket. This is an example. I will give 5. This is the bucket capacity, and the refill rate is 1 per 5. That means after 5 seconds, we'll add 1 to the bucket capacity for this user. Let's see how is the pattern. You can see here for the user after 5 attempt is allowed, because it's within bucket capacity. And during 5, in number 6, the refill rates start to add 1 token. So for number 6, also allow the user to send. For number 7, now start to block the user because the bucket is empty. After reach the time 10 second. So is the time to refill again one bucket to this user. So in attempt request number 11, he allows user to send his request. Similarly, in time 15 seconds is the time for allow to add one token to the bucket of the user. And the number 16 for request is allowed to the user. And then start to block again because in this time, the bucket is empty. So, if we make comparison between fixed window and token bucket, the main advantage for the token bucket is it allows the user to send not huge bucket size as in case of fixed window. Because fixed window in its pattern, it does not allow the user for a long time within the time specified to send any request. This causes accumulated tokens, and once the time windows start, the user accumulated token is sent in one time. This causes users send huge token burst of tokens for the fixed window. But in token bucket, every refill rate one token will add, so it not allow the user to accumulate huge tokens till waiting for the next allowed time. This is the main difference between them. Take a look at the timelines. With fixed window, the user can send requests continuously until the limit is reached. Once that limit is exceeded, every additional request is blocked until the entire time window resets. That creates one long continuous block, followed by another burst of requests when the new window begins. Now compare that with Token Bucket. Each request consumes one token, while new tokens are added back gradually over time. When the bucket becomes empty, requests are temporarily blocked. But instead of waiting for a full reset, the user can send another request as soon as enough tokens have been refilled. The result is smoother traffic, fewer sudden bursts, and a more consistent load on your API. So the key difference isn't simply that one blocks and the other doesn't. It's that fixed window blocks continuously until the reset, while Token Bucket blocks only temporarily, allowing requests to resume gradually as tokens refill. That's why Token Bucket is generally the preferred choice for production systems handling real user traffic. Before you deploy your rate limiter, keep 3 things in mind. First, if your application runs on multiple servers, don't store counters in local memory. Use a shared store like Redis so every server sees the same usage data. Second, not every user needs the same limits. Free, Pro, and Enterprise users can each have different rate limits using the same mechanism. Finally, always display a clear message when a user reaches the limit. Tell them they've hit their limit and when they can try again. A good user experience builds trust, even when requests are temporarily blocked. That wraps up Layer 3, Call Reduction. Let's quickly recap what we've covered. Exact caching eliminates identical repeated requests. Semantic caching recognizes the same question, even when it's asked in different words. And per user rate limiting ensures that no single user can consume an unfair amount of your API budget, regardless of what they ask. Together, these 3 techniques reduce the number of API calls, helping you lower costs while protecting your application from unnecessary traffic and abuse. But reducing the number of calls is only part of the optimization story. The next step is reducing the cost of each call. In the next episode, we'll begin Layer 4, Cost per Token. You'll learn how to automatically route simple requests to a smaller, faster, and cheaper model, while reserving your most powerful and most expensive model only for complex tasks that truly require it. If you found this episode helpful, Don't forget to like, subscribe, and share your rate limiting questions or experiences in the comments. Thanks for watching, and I'll see you in the next episode.